Hey, what's up, guys? Today, let's look at Lintcode problem number 93, balanced binary tree. You were given a binary tree, so we need to determine if this is height balanced. So for this problem, a height balanced binary tree is defined as a binary tree in which the depths of the two subtrees of every node every differ by more than one. So for example, we have two trees, A and B. So obviously A is a balanced tree because every node, every subtree, their height difference is only just, not more than one. But for B, if we look at the node 3, the left children, left subtree height is 0 and right subtree height is 2. So the difference is 2, more than 1. So B is not a balanced tree. Okay, so by this definition, let's see how we resolve this problem. Is balanced is our entrance. We can directly go inside this code. Um, First, we need to know that we're dealing with this binary tree stuff. So for tree stuff, they usually have the symmetric system, symmetric structures. So usually we will use divide and conquer. In most cases, like 99%. So this question, we're gonna use divide and conquer to do this. So let's see, how do we do that? We write a function it's called helper. This helper is a divide and a conquer function. So this helper is gonna help us to calculate the tree, the given tree, which is the root. We'll calculate if this tree is balanced and also return its height. So we just return is balanced or not. Now let's look at our core function, the helper. So we need to calculate the tree height and check if the tree root is balanced. So since the helper is using the divide and conquer, so we need to check the termination conditions to see when we should escape from this function. Um, if the root is null, then we're going to just return. We will see that a noun tree is a balanced tree and its height is 0. All right. Then we will do a divide and conquer. We'll calculate the left tree if the left tree is balanced, and we calculate left height. And same thing, we calculate right tree is balanced and right tree height. So we just by self calling ourselves, we just pass different subtree. This is left tree. This is right tree. All right. So divide part is done. Let's see what do we do with the conquer. So to determine if the current root is a balanced tree, we have several conditions. The first, we need to make sure that our left tree is balanced and our right tree is balanced. And also the left height minus right height. So we just give the absolute value. If their height difference is less than 1, then we'll say, yeah, this is the balanced tree. And we just return the height. Remember how we define the height of a tree? We just return the maximum value from the left height and right height. We choose the you know largest one and plus 1 because the root also takes 1 height. So only this satisfies, then this is the balanced tree. If not, it's gonna be a it's gonna be a not balanced tree. So height is the same calculation formula. Yeah, so this is our algorithm. It's very simple. Okay, let's just do a summarize. And this is balanced tree. We're gonna just use divide and conquer. So in our main function body is quite simple. We just call this helper function. We get our answer, which is a return. And the core logic is here The helper is a divide on and conquer algorithm. So we need to first, every time when we write a recursive call, we need to first put our termination condition here. Then we will use divide and conquer. Then the most important thing actually is this conquer thing. Actually, a lot of people, they don't do this. They just calculate the left height, calculate the right height, and they just check this height difference. But we have to know that the calculate the subtree, if that subtree is balanced or not, is highly important. Even though the two subtrees, they have the the less than one height difference, but one of the subtree is not balanced, then we cannot say that tree is balanced. So remember, this is very important. You got to calculate if they are balanced or not. Then remaining is just pretty simple. This is how we calculate the tree height. Yeah, so this is the algorithm. Let's run it. Yeah, so looks great. So everything is working and all the test cases passed. And thanks, that's today's algorithm. Bye if you like this video, and please subscribe so that you can get my latest algorithm informations. Thanks, bye.